Hello children, good morning all of you. I am P. Srinivasarao, PGT Chemistry from JNV Rangareddy. So today I am in front of you to discuss about some chemistry topics. So before going to discuss about the chapter structure of the atom, let me know first of all something what you know previously. So let all of you know that about the matter. What is matter? In first chapter you have studied what is matter. Yes, you are correct if you say that matter is anything which occupies some space and having mass. So around us we have matter. So both visible and non-visible things like gases are belongs to the matter. Now this matter we have studied about is made up of particles. And also studied matter is made up of particles. This was given our Indian philosophers, Greek philosophers discussed about this, the particle nature. Matter is made up of small tiny particles. The Maharshi Kannad has explained or given that matter is made up of particles. Maharshi Kannad. Similarly, our Greek philosophers also, Democritus, Leucippus also indicates that the matter is made up of small particles which are indivisible. Later, Dalton again postulates some points. Dalton postulates are studied in our previous chapters. Some of the important points of Dalton postulates are matter is made up of tiny particles. Matter is made up of very tiny particles called atoms. And then atoms are indivisible particles. Third one is atoms of different elements have different masses and different chemical properties. These are some important postulates given by Dalton. What Dalton says? First is matter is made up of very tiny particles, very small particles which are not divisible according to Dalton. Next one. Atoms of different elements have different masses and different chemical properties. This was given by Dalton. So scientists, present day scientists, think about why the matter is showing different, having different particles and different properties. The different atoms having different properties. That is the last point. Different elements have different masses and different chemical properties. What makes the atoms differ? That is our question now. Matter is made up of tiny particles, but different types of substances showing different properties. So what makes them differ? Moreover, what Dalton says, it is indivisible. Is it really indivisible or anything inside? That is another question in the minds of the scientists. So experiments continued. One experiment, very simple experiment you can take, that is if you comb your hair, that comb will attract some piece of papers. So from where the charge, how it will attract in the piece of papers. Similarly, if you rub a silk cloth with ebonite rod, they will develop some charge. From where the charge comes? Because atoms are neutral, no charge, but these experiments, that is rubbing of the silk cloth along with the ebonite rod, they are giving some charge. Similarly, combing of hair, particles are coming. From where this charge comes, that again gives further development of the science. Is it really indivisible or maybe inside? Maybe something inside, so that that charge is coming out and attracting the other pieces. So experiments continued to show that there may be something inside the atom. So in this context, J.J. Thomson is the most important person. He is conducting some experiments. So to see what is inside the atom, the experiments continued. So there may be something inside. Experiments are continuing. So in that, one of the most important experiment is cathode ray tube experiment. One of the most important experiment is cathode ray tube experiment. It was conducted by J.J. Thomson. J.J. Thomson cathode ray tube experiment. In this, he has passed so much voltage, high voltage, and very less pressure applied through the tube, so that he identified that some particles are coming from one side to other side. Those particles are named as electrons. The surface, in this surface, this experiment is not there, so directly you can go to that experiment, giving us some small idea, that is the particles, the atoms is giving some particles known as electrons. So J.J. Thomson invented the electrons, where the electrons indicated with E minus. Electrons are coming out, that is indicated with E minus. And the properties we take these electrons are negatively charged. Their charge was taken as -1 unit. It is not actual charge, that whatever the charge it is containing, it was taken as -1 unit. And the mass of this electron particle is negligible. The mass is almost negligible. It is 1/2000th part of the proton mass. Proton is not discovered by that time, but later it was identified that it is 1/2000th part of the proton mass. So these three we have to remember. Electrons are indicated with E minus, and these are negatively charged, and their mass is negligible, equal to 2000th part of the mass of the proton. These electrons are coming from the material or matter atoms, that is from this cathode ray tube experiment it was identified. Now once electrons are there inside the atom, but atom is neutral, but atoms are having negative charge, so how it is neutral? There may be some positively charged particles may be inside. So those positive charged particles also identified later, that is based on the same cathode ray tube experiment. In that case, canal rays are identified, where the positive ions identified, positive particles are identified. These positive particles are identified by E. Goldstein in 1886. In 1886, positive particles are identified by E. Goldstein. In that experiment, same experiment, that is cathode ray tube experiment, and those positive charged particles are named as protons. These particles are named as protons. Protons are indicated with P plus, and their charge, because it is positive, it was opposite to the electron charge, taken as +1. Proton charge is +1. Protons are indicated with P plus, and it is 2000 times to the mass of electron. That is previous point, the same thing reverse we are writing. It was taken as 1 unit. So electron, proton are identified. Electron is negatively charged, E minus, whereas proton is positively charged, P plus. Electron charge is -1, whereas proton charge is +1. So both together get neutral. And mass is equal to 2000 times to the mass of electron, taken as 1 unit. The proton mass was taken as 1 unit, 1 small you have to write it. So electrons and protons both are discovered, which are present in the atom. Now these two, if equally present in the atom, in total atom will be neutral. Once after identifying this electron and proton, then what is the arrangement of these particles in the atom? That is our present chapter, structure of the atom. Discovery of the atom is not there, our particles. Only the structure of the atom is how these particles are arranged inside the atom. Suppose you are sitting in the classroom, maybe some 40 members are there, on each bench 2 members or 3 members will sit in a particular way. Or you may sit in a round, or you may sit in a square. Maybe one type of pattern you will follow. So in the same way, inside the atom, how the particles are arranged, they have to identify. That is our present chapter, structure of atom, how these particles are arranged inside the atom. So by the discovery of this electron and proton, now what Dalton says is not correct. What Dalton said? He told that atoms are indivisible. But inside the atom, electrons are there, protons are there, electrons are coming. So it is not indivisible, it is divisible now. So according to modern views, we can say that atoms are divisible. The prime part is now how these particles are arranged inside the atom. That is our prime topic. So how this arranged? For that again, you know that the atoms are very small particles which you cannot see. But even then, inside the atom, how the electrons are present, how the protons are present, how they are arranged, how many are there, again there is a big question mark. It is very difficult to identify it. But even then also, they try to explain their arrangement. Out of that structure of arrangement, the first one is again Thomson proposed some particular theory. Structure of atom, Thomson model. Thomson proposed a model where he assumed that atom is in a spherical manner compared with a watermelon. If you compare, atom is equal to watermelon. Inside, red pulp will be there, which indicates the entire positive charge. Inside, again seeds are there, they are embedded in the red pulp, which can be considered as electrons. So how electrons as seeds and the red pulp present in the atom, in the same way positive charge and electrons are present inside the atom. In that way, the J.J. Thomson proposed his model, Thomson model. So Thomson, according to Thomson, he proposed that, see here, this is an atom. This entire atom is having some positive charge and electrons are embedded here. So this is the proposed by the Thomson model. So electrons are embedded, means they are get in contact. But you know that it is positive charge and it is negative charge, they should not get in contact. Otherwise, if they get in contact, it may be spoiled, it may be broken out or may be destroyed. So what happens now? It should not be there. It should not coincide. So whatever the proposed, this is the first model we are discussing because he has some idea regarding the arrangement of arrangement of the particles inside. So we are studying this one as a Thomson model. What he proposed, atom consists of positively charged sphere and the electrons are embedded in it. A positively charged sphere and electrons are embedded here. The negative and positive charges are equal in magnitude, so that atom is heavily neutral. Next, what is the drawback of this one? It could not explain the results of Rutherford's alpha-ray scattering experiment. This is another part. Once J.J. Thomson proposed a model where the atom is consisting of the electrons and protons inside. Protons are totally spread over the atom. Electrons are embedded. But whatever he says, only logical thinking, there is no experimental proof. So to prove that, Rutherford tried his best. But whatever Rutherford got the results, those results are not explained by the Dalton's model. So Dalton's model is somewhat incorrect. So we have to modify it by using the Rutherford model. Next we have to go to the Rutherford model.